I want to talk about a new concept called concavity. Now, concavity describes the curvature of the graph of a function. I have four kinds of graphs here. The first two are both concave up, but this is an example of a graph that's concave up and decreasing. This is an example of a graph that's concave up and increasing. And if you're confused about what identifies as concave up, you can draw some tangent lines. If you draw tangent lines, you'll find, and you extend them, you'll find that the tangent lines lie below the graph. The concave up graph lies above them. And it's the same thing whether the graph is decreasing or increasing. So, a concave up graph lies above its tangent lines. Now, if a graph's concave down, it'll do the opposite. The tangent lines will be above the graph. So, in both of these cases, the curve lies below the tangent lines. That's concave down. Now, a concave up or concave down graph can be increasing or decreasing, and that's why we get these four different kinds of curves. Now, what you'll need to know on your homework is how to test for concavity, and concavity has to do with the second derivative. If you think about it, each of these tangent lines, its slope comes from the first derivative, and in this picture, the slope, these all look negative, but the slope would be actually increasing. Like, say this is -5, this might be -2, -0.5. The slope's actually increasing. And the same thing's happening here. Maybe this is a slope of 1/3, 1, 2. Slope is also increasing. So when a graph is concave up, the slope of the tangent lines is increasing. That means f prime is increasing. F double prime is positive. Now, when a graph is concave down, the opposite's happening. The slope of tangent lines is decreasing, right? This might be -1, this might be -2, -4. And over here, you've got positive slopes, like maybe this is 5, this is 1, this is not very well drawn, this is maybe 1/4. The slopes are decreasing here. And so you'd say that f prime is decreasing or f double prime is negative. And that's where the concavity test comes in. If you have a function f, and I is some interval in its domain, if f double prime is positive on an interval for all x in that interval, then f is concave up on that interval. And if f double prime is negative, then f is concave down. So whether or not a function is concave up or concave down depends on whether the second derivative is positive or negative. Positive means concave up, negative means concave down. Now there's one other term I need to tell you about, and that's inflection point. It is possible for a graph to change concavity, like, for example, something like this. Here the graph is changing from concave down to concave up. The point where that happens is called an inflection point. It's a point on the graph where the concavity changes. And the way you check for that is you look for changes in sign of the second derivative. So again, where the second derivative is positive, the graph's concave up. Where it's negative, the graph's concave down. And when that sign changes, you have an inflection point.